I never thought that we'd get to this stage. What I want to do is to tell you a bit about the origin of the CSD and the early developments and the ideas that were embodied at that stage, which hopefully are still valid today. Well, what's happening?
Hello. Press this button.
Oh, yeah. Okay.
Let's see if that works. Okay.
Right, right. This is Stonehenge. Actually, the CCDC doesn't go back as far as that. But it does go back to that dominating figure in the center, J.D. Burnell, and myself, a young woman around 1952, listening to him absolutely entranced. Burnell was one of the most outstanding scientists of his generation. He had a great ability to foretell coming developments well ahead of anybody else. For example, he believed that the three-dimensional structure of proteins would one day be solved, and that it would make a great difference in biology. As you all know, that has come true. But above all, he was one of the first people who recognized both the dangers and the opportunities provided by the rapidly increasing volume of scientific information. He was one of the organizers of the first International Conference on Scientific Information at the Royal Society in 1948. And he made some very controversial suggestions. Above all, however, he believed passionately that if one could bring together the results of many individual experiments, this would lead to new insight, new knowledge. He also thought that once in a certain field sufficient information was collected, there would be no more need for any more experiments. I'll come back to that point a bit later. I was a young and enthusiastic student who soon joined in Bernard's belief that there was something really wonderful to be got out of looking at scientific information. And I was more than eager to join when he suggested that we examine the influence of molecular shape on crystal packing. Actually, this is a topic which Robin Taylor looked at quite recently from a different point of view. We managed to get a small grant to employ one postdoc who transferred information from about 100 crystal structures to edge-punched cards. And then, to pick up the similarities, we used knitting needles, a very far cry from today's search programs. We thought that the only way to disseminate any results we had was via a printed book. And we actually had a contract, which I have a copy of still, with the Cambridge University Press. Unfortunately, Burnell's health deteriorated, and that particular project never came to fruition. However, the project we started at Birkbeck had some very unexpected consequences. What happened was that around that time, that's about 1963-64, the entire world of data collection was dominated by the US and the USSR. And scientists in various countries became concerned that it would be a monopoly of the superpowers. It was a time of the Cold War, of course. So a special committee of IXQ was set up, and different countries were asked to name areas of science which they wanted to support and present these results at a meeting in Washington. So the Royal Society and a newly formed government department for scientific information sent a scout around the country to talk to people at universities and see what on earth could be found to be supported. And behold, the scout found our knitting needle enterprise at Birkbeck. So it was decided that this surely was the right thing to support. I was asked to prepare a grandiose plan for a data center, which was to involve both experimental research and data compilation. I presented that at a meeting in Washington, and the agreement was passed. The way ahead was open. In reality, of course, what I got in the end was a very small grant. It was just for one postdoctoral and one assistant to join the chemical crystallography group that Colin has alluded to. I was very clear that the post should go to a working crystallographer, because I felt that only that sort of person would be attuned to the needs of crystallographers, and also because I felt it very important that we should remain fully integrated in the international crystallographic circles. The first person to join was David Watson, who is here today. And a couple of years later, Sam Motherwell. And here they are, and myself, many, many years younger, poring over something that could be a data output. On the other hand, it could be a crystal structure. People were doing alternately data and structure, 1 week on one assignment and one the other. A few years later still, Bill Town followed, and then Frank Allen, who sadly is no longer with us. These were an extraordinarily talented and energetic group, and the database owes so much to them. The last person I'd like to mention, whose name is also familiar to you, is Robin Taylor. Now, Robin joined us in the early 1980s, after the period that I'm going to cover, and he pioneered the use of research based on the CSD at our center. He will be talking about that, I see, later in the meeting. When we started, this was the situation. 2,000 structures up to end of 59, another couple of thousand unto 64, and shooting up to 8,000 by the end of the decade, and then, of course, right up nearly 18,000 by the end of the period I'm going to speak about. As you can imagine, it was a daunting task, and we were lucky to have started when we did, because I think it would have been really difficult, especially in that climate and attitude about information, to have caught up at all. The first thing we did was to concentrate on the bibliographic file. We managed to collect reprints of papers published in the period before 65 and then keep collecting new ones. with the help of the French information service Bulletin Signalétique. We decided to introduce one idea in this database, which was to assign to each structure that was entered into the bibliographic file the now familiar ref code. 6 letters as an acronym of the name and 2 digits. And I see from some discussion in various blogs that actually it's still useful. There's a one entitled, I am not a number. That's the ref code. The ref code actually was a very good concept because it managed to link the various files as they were developed. We also were aware that there was a possibility of computerized typesetting. The thing that was missing was programs. But as you can imagine, that didn't daunt people working at the CCDC. They, in collaboration with the Atlas computer laboratories, developed a set of computer setting programs, and we also managed to find a printer who had the necessary equipment and whose printing union didn't object to it too much. The first volume in the Molecular Structures and Dimensions series was actually only ready in 1970. So you see, it took us quite some time to tool up and get going. The 2 volumes which appeared at that time were both dedicated to Bernal, who at that time had already suffered some strokes and was in a wheelchair. And I can very well remember taking those books and how touched I was, almost in tears, and the way Sage tried to acknowledge the gift I brought him. There were another 14 or so volumes up to 1982. And if you think about it, it's really quite a long time for the printed edition to be superseded by the online systems. The other aspect of this publications was that we introduced a rudimentary element of searching, partly by a permuted name index, and also by dividing the entries into 86 classes, 86 or 87, by the very simple expedient of David taking a whole stack of cards with the entries and dealing them out into equal parts with the help of a textbook. I hope you remember that, David. The next stage was the data file, to build up the data file. And here, there are 2 very important concepts which I'd like to talk about. The first one was the accuracy of the database. Before I started even, I was actually offered a ready-made database by Ray Pepinski. But I realized that it had never been checked, so I said, no, thank you. But we were determined that our database will have numbers that could be relied on. So a most elaborate set of checks was introduced, including the recomputing of the distances from the coordinates and communicating with the authors to sort out any problems and errors. You'll be surprised just how many errors there were at that time. We felt that once we had done that and obtained such a rigorously checked database, people could really use it with confidence. And I think that has come true. The second idea was not to use the atom coordinates as listed in the paper, but to use the atoms and the symmetry-related atoms transformed to orthogonal coordinates. Now, you probably are oblivious about this, and it seems a very simple idea. But it was very unorthodox at the time. I think it made an enormous difference in the use of the database by non-crystallographers who didn't know the intricacies of crystal symmetry. And I think it contributed greatly to the rapid take-up of using the system by the community outside the crystallographic world. Now, what did we do with this database? Well, again, we were at that time still thrown back on the printed book. And we did produce 2 volumes of interatomic distances, 1960 to 1965. This contained a computer-drawn diagram of the molecule, certain fundamental and bibliographic data, bond lengths and bond angles, and a hand-drawn chemical diagram on the top. To assemble it, we used professional editors. As you can imagine, it was an enormous amount of labor. It was a labor of love, never ever to be repeated again. This was the first and last set of volumes of the interatomic distances. Fortunately, by that time, the third file, the chemical connectivity file, the CON file, had also been developed. Well, as you know, that has the atoms, bond types, number of connections, charge, and is a way of developing substructure and substructure searches. And this was done by the team in Cambridge. So the flow chart of what it looked like at the time is here. You see the CON, BIB, and structural data files retrieved using the ref codes, and then we had determined the geometric, geom, Pluto, and for the life of me, I can't remember what plot was. At around that time, the CCDC rather, began to run into trouble because the powers that be said to us, it's all very well, you say information is important, but if so, get somebody to pay for it. And at that time, it was almost unthinkable to pay for the information. You just sent your postdoc or your research student to the library. So I was talking about this at an international crystallographic conference, and one of my friends there, actually it was in a bar at night, came to the rescue saying, I've got some money left over from a grant, which I'd have to give back at the end of the year. I'd rather give it to you, and you let me have the database. And this is truly the beginning of the national data centers. It was followed quite rapidly by Italy and Japan, and then the whole thing snowballed, and one country after another joined. And as we perfected the system, the industrial companies, particularly those companies that had employees who used to be students at universities and had free access to the database, realized that they also needed to have that in-house. So they offered industrial support. And in this way, the very unusual dual support system, independent of public grants, was established. And I'm very happy to see that it has served the database and the data center well over these very many years. The rest actually you all know. The exponential increase in the database reaching 7,000 700,000 entries last year. The enormous changes in the input and check procedures, and most importantly, the addition of two knowledge bases, ISOSTAR and MOGO. But I think that the basic ideas we established earlier and I was talking about still hold good. Now, to finish, I'd like to ask a final question. How far was our initial dream realized? Some of it actually, I think, was not realized. If you remember, I mentioned that we thought that provided enough information was obtained in a certain field, there'd be no more new experiments needed. Now, curiously, the number of small molecule structures published is still increasing, and I'm not sure why. But the other aspect, that it's worthwhile spending effort on looking at information from many individual experiments, would definitely lead to new insight, new knowledge. And this is indeed testified by the many thousands of papers published, and I'm quite sure by some of the papers that will be presented at this meeting. Thank you very much.